Hello, viewers, and subscribers. There is another video in statics, particularly on resolving a force into its components. I hope that through this video, your knowledge in statics will be enhanced and improved further, preparing you to become better engineering students. So here we go. The components of the force F and force F are Fu 120 newtons at theta u 25 degrees and Fv equals 150 newtons at theta v equals 115 degrees. Determine the force F. Also resolve it into x prime and y prime components, where x prime axis is negative 40 degrees, so that's clockwise from the positive x-axis, while y prime is 120 degrees from the positive x-axis, so that's counterclockwise. So let's draw the figure locating the the force F and showing the U and the V components. So this is Fu and it makes 25 degrees with a positive x-axis, 120 newtons, and the V-axis makes 115 degrees from the positive x-axis, so 115 minus 90 degrees is 25 degrees. So that means Fu and Fv are perpendicular to each other. So the resultant, which is represented by the diagonal of supposedly the parallelogram, which reduces to a rectangle, is this vector represented by the yellow arrow. Now, the magnitude of F is simply by Pythagoras theorem square root of Fu square plus Fv square because the components are perpendicular to each other, or the axes U and V are perpendicular to each other. So F is square root of 120 square plus 150 square. So that means F is equal to 192.1 newtons. So that's the magnitude of the force F. Now let's solve for theta, noting that this is a right triangle. From the figure, tangent theta is Fv divided by Fu. So tangent theta is 150 over 120. And solving for theta, theta is equal to 51.34 degrees from the u-axis. So that means F from the x-axis, we add 25 degrees. So theta x is 51.34 degrees plus 25 degrees. So that is theta x equals 51.34 degrees plus 25 degrees. So theta x is equal to 76.34 degrees. Now we finalize the answer because f is a vector and we have here the problem f, which is boldface. That means f is treated as a vector. So the final answer will be magnitude and the angle that f makes with the positive x-axis, 76.34 degrees. So f is 192.1 newtons at theta x equals 76.34 degrees. We now uh, resolve this force into the x prime and y prime components. To do that, let's draw the force with magnitude and let's also draw the x prime and y prime axis. So this is the situation. This is fx prime, that's fy prime. This is the parallelogram, and that's the force of magnitude 192.1 newtons, making an angle with the x-axis of 76.34 degrees. Since this angle is 40 degrees, 40 plus 76.34, this total angle is equal to 116.34 degrees. So let's consider this triangle here, this triangle here. Then uh, fx, call that fx prime. This is parallel to the y prime axis, so this is fy prime. Now the measure of this angle is equal to, let's solve for this angle first, the angle that f makes with the y-axis, and that is equal to 90 degrees minus 76.34 degrees, so that's 13.66 degrees. So 13.66 degrees plus 30 degrees, y prime axis makes an angle of 120 degrees from the positive x-axis. So from the y-axis, it makes 30 degrees, which is this. So 30 degrees plus 13.66 degrees is 43.66 degrees, and the measure of this angle is equal to the measure here, which is 43.66 degrees. While this angle here is simply 180 degrees minus 116.34 degrees, then minus 43.66 degrees, and that is equal to 20 degrees. Finally, uh, applying the law of sines in this triangle here. So we have fx prime as to sine of 43.66 degrees equals fy prime as to sine of 116.34 degrees equals 192.1 as to sine of 20 degrees. So again, fx prime as to sine of 43.66 degrees equals fy prime as to sine of 116.34 degrees equals 192.1 as to sine of 20 degrees. Solving for fx prime, it is 192.1 times sine 43.66 degrees divided by sine 1 of 20 degrees. So fx prime is equal to 387.8 newtons, while fy prime is equal to 182.1 sine of 116.34 degrees divided by sine of 20 degrees, and fy prime equals 503.3 newtons. So that's it for this video. I hope that you were able to follow the explanations and the solutions. So take note that in resolving a force into its component, we just apply the law of sines, or we apply plane trigonometry, concepts in plane trigonometry, and we just simply solve the triangle using the law of sines, or if the law of cosines are also applicable, then apply that law of cosines. So that's it, and I hope that you enjoyed watching. Bye bye.